Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
If you break your arm, an X-ray gives you this really clean, jagged white line, right?
Exactly. You can see the exact point of failure.
Right, and it's comforting in a
Right.
weird way. I mean, you can see the problem, you point at it, the doctor points at it, and, well, you fix it.
We really do rely heavily on that visual confirmation, don't we? If we can categorize the threat, if we can map it out on a table, we feel like we can control it.
Yeah, exactly. But what do you do when the X-ray machine is, utterly useless?
That is the big question.
Right. What happens when the forces that actually dictate your life, whether that's the literal bedrock beneath your house or the microscopic code running a spacecraft, or even just the subtle psychological shifts driving global diplomacy, what happens when all of that is completely invisible to you?
Well, you're forced to look at the secondary effects. You have to look at how those invisible forces sort of warp the world around them. And that is incredibly unsettling for most people because it requires us to abandon the illusion that we have everything under control.
I mean, speaking of unsettling, if you're living in Seattle, Washington right now, hearing about invisible forces under your feet is probably the last thing you want.
Oh, absolutely. The Pacific Northwest is already on edge.
Right. Everyone in that region of the United States knows about the big one. They know about the Cascadia subduction zone, where the oceanic plate is, shoving its way under the North American continent.
Yeah, that's a known quantity. We've been tracking that for decades.
Exactly. But geologists have just mapped something else entirely. They found these blind secondary faults.
And a blind thrust fault is basically a nightmare for urban planners.
Why is that? I mean, a fault is a fault, right?
Well, not exactly. When a standard fault ruptures, like, say, the San Andreas down in California, it breaks the surface. You get a visible scarp, a literal tear in the dirt.
Okay, yeah, you can physically see the crack.
Right. Geologists can walk right up to it, dig a trench across it, and carbon date the organic material trapped in the layers. It lets them perfectly reconstruct the history of past earthquakes.
But a blind fault, it never breaches the surface, does it?
Exactly. It's entirely buried, usually under thousands of feet of sediment.
Wow.
In Seattle's case, the Puget Lowland is just filled with glacial deposits. So the fault is grinding away deep underground, building up all this immense stress, but the surface looks perfectly serene.
Which gives people a massive false sense of security. I mean, researchers are looking at these newly discovered blind faults beneath Seattle, and they're finding a periodicity of roughly 350 years.
Yes, that's the current estimate based on the new mapping.
And they actually trace this back to a massive megathrust earthquake that happened around 923 CE.
That's right.
And what's really incredible to me is that this event was meticulously recorded in Native American oral histories.
It's fascinating how accurate those oral traditions are.
Right. The local tribes passed down these vivid stories of the ground turning to liquid and massive waves just wiping out coastal villages. And now, modern data suggests there's a 37% chance of another megathrust event in the next 50 years.
And when a blind fault ruptures, the danger is actually amplified by the very thing that's hiding it.
Wait, what do you mean? How does the dirt make it worse?
Well, the seismic waves hit that deep basin of soft glacial sediment that cities like Seattle are on, and that sediment, it acts like a giant bowl of gelatin.
Oh, man. So it just jiggles.
Basically, yeah. It traps the waves, causing them to bounce back and forth, which massively amplifies the shaking at the surface.
Okay, hold on. Let me stop you right there, because a 37% chance in 50 years is a terrifying statistic to just drop on people.
It is a sobering number, yes.
Is this a situation where geologists are just, modeling worst-case scenarios to secure grant funding? What is the actual actionable takeaway here? Because you can't just pick up the Space Needle and move the city.
That's a fair question, and there's always a healthy debate regarding the predictive models of seismology. Some argue that focusing too heavily on long-term probabilities distracts from immediate infrastructure needs.
Right, like fixing potholes instead of worrying about an apocalypse.
Exactly. But the actionable takeaway here isn't about panic. It's about precision engineering.
Okay, how so?
If you're an urban planner and you only build a skyscraper to withstand the lateral forces of the known visible faults, you're leaving a massive vulnerability.
Because you're ignoring the bowl of gelatin.
Exactly. Knowing these blind faults exist forces a complete recalculation of the local building codes. It changes how deep bridge pylons have to be anchored, and it dictates the resonant frequency that modern skyscrapers are designed to absorb.
Oh, I see. So it shifts the paradigm from just hoping it doesn't happen to engineering a city that expects the ground to move in very specific, previously undocumented ways.
Precisely. You engineer for the invisible threat.
Nature doesn't only hide the hazards, though. Sometimes it actually hides the safety features.
That's true. We're seeing some amazing discoveries on that front.
Yeah, if we look further south, along the Pacific coast, down to Ecuador in South America, scientists just found something that does the exact opposite of what's happening in Seattle. They discovered these tectonic breaks.
Yes. This completely upends how we traditionally view subduction zones.
How so?
Well, we're looking at a specific segment of an underwater fault near the Ecuadorian coast. Normally, an oceanic plate grinding under a continental plate builds up friction until it snaps.
Right, which causes those catastrophic magnitude 8 or 9 quakes we always hear about.
Exactly. But this specific fault has these highly unusual zones where seawater has deeply infiltrated the rock.
And instead of building up to a massive disaster, this fault reliably releases like magnitude 6 earthquakes every 5 to 6 years.
It's a remarkable natural mechanism. In seismology, we focus heavily on the friction coefficient. How locked together are the two tectonic plates.
Okay.
If they're perfectly locked, they'll drag each other for centuries until the rock simply cannot take the strain, resulting in a catastrophic release of energy.
But wait, if seawater infiltrates the rock, wouldn't that just act as a lubricant? I mean, wouldn't that make the plates slip faster and more violently?
You would think so. And it does act as a lubricant to some degree, which allows for the more frequent slipping. However, it's the structure of the rock itself that acts as the brake.
The structure of the rock.
Yeah. The researchers found that the rock in this zone is heavily fragmented and features highly irregular, rugged structures. So when the plates slip, the energy doesn't travel cleanly.
Oh, it gets stuck.
It hits these rugged zones, these baffles, really, and the fluid-filled fractures absorb and scatter the seismic waves.
That's wild. It's almost like the crumple zone in the front of your car.
That is a perfect analogy. A crumple zone is designed to deform and absorb the kinetic energy of a crash so that the passenger cabin remains intact.
Right.
This Ecuadorian fault is essentially deforming and absorbing the kinetic energy of the tectonic shift, limiting the magnitude and preventing a city-leveling disaster.
It's nature actively mitigating its own chaos, but, when we talk about tectonic plates, we usually think of them as these slow, silent forces that just occasionally cause an earthquake.
They are much more than that.
Yeah, we forget that they are the primary architects of the planet, which brings up this massive realization about the lost Tethys Ocean.
The Tethys. It's basically a ghost ocean.
Right.
It dominated the globe from the late Paleozoic through the late Mesozoic era, separating the supercontinents of Laurasia in the north and Gondwana in the south.
And for as long as I can remember, the textbook explanation for the massive mountain ranges in Central Asia, like the Himalayas, the Tian Shan, was always that the Indian subcontinent just slammed into the Asian plate.
That was the standard model, yeah.
And we assumed that was driven mostly by deep mantle convection, basically the boiling rock deep inside the Earth pushing the plates around, maybe aided by some extreme climate shifts. But this new geological data completely rewrites that.
It really does.
It turns out the Tethys Ocean didn't just passively close up. It was the primary engine that built those dinosaur-era mountains.
The mechanism here is what geologists call slab pull, and it completely reshapes our understanding of global topography.
Okay, break that down for us. What is slab pull?
Well, we used to think of continental drift primarily as a push mechanism, but oceanic crust is significantly denser and heavier than continental crust.
Because of all the water.
Partly the water, but also the composition of the basaltic rock. As the massive, dense crust of the Tethys Ocean began to subduct or sink beneath the Eurasian plate, it didn't just melt away harmlessly.
Right.
That immense sheet of heavy rock sank into the mantle, and as it sank, it created an overwhelming gravitational pull.
Almost like a tectonic suction.
Exactly like that. The sinking ocean floor physically dragged the continental plates behind it, pulling India toward Asia with far more kinetic force than mantle convection could ever generate on its own.
That is just crazy to picture.
The Tethys Ocean essentially sacrificed its own existence, using its dying gravitational weight to push the roof of the world into the sky.
It's incredible. The ocean that vanished is the very reason the highest peaks on Earth exist today.
It's a beautiful geological irony.
But this theme of the past, constantly bubbling up to correct our assumptions, doesn't stop with shifting rocks. It applies directly to us. Paleontology and archaeology are going through a massive tech-driven renaissance right now.
They really are. The imaging technology, combined with advanced isotopic dating, is allowing us to extract vast amounts of data from fragments that would have been scientifically useless 20 years ago.
Let's look at the Afar region in Ethiopia. Researchers just uncovered a hominin skull. It's 3.8 million years old.
Wow.
And it belongs to a species called Australopithecus anamensis. And this single skull is effectively taking a sledgehammer to one of the most famous illustrations in human history.
You're referring to the March of Progress illustration, I assume.
Yeah, exactly. The linear progression of a knuckle-walking ape slowly standing up, becoming a Neanderthal, and finally becoming us.
Right. It's deeply ingrained in our cultural psyche. We tend to think of evolution as a relay race.
Right. One species runs its leg, passes the baton to the next, and quietly goes extinct. For a long time, scientists thought Australopithecus anamensis was the solitary direct ancestor to Australopithecus afarensis.
Which is the famous Lucy fossil that everyone learns about in school.
Exactly. We thought the first one just slowly morphed into Lucy's species.
But this new, remarkably intact skull from Ethiopia proves otherwise.
How so?
By precisely dating the sediment layers where it was found, researchers have definitively shown that anamensis and afarensis actually coexisted for at least 100,000 years.
Wait, they shared the exact same landscape.
They did. It forces us to replace that linear ladder of evolution with a very messy, heavily branching bush.
A messy bush. That's a great way to put it.
It means evolution is not a clean progression, It's a chaotic, simultaneous survival tournament. Multiple variations of early hominins were sharing territories, likely competing for the exact same food and water source, and testing entirely different evolutionary survival strategies against the same environmental pressures.
I just cannot get over that image. Just standing on a ridge in Ethiopia 3.5 million years ago and looking across a valley at a completely different species of early human that's hunting the exact same animals you are.
It's a humbling thought. We weren't the only ones trying to figure it out.
But we don't even have to go back millions of years to find our assumptions being overturned. If we jump forward to the Neolithic era around 6,300 years ago, we're finding that the social structures of our closer ancestors were a lot darker and a lot more familiar than we really wanted to believe.
Ah, you're talking about the recent excavations in Spain, specifically in Valencia de la Concepción.
Yes, exactly. Archaeologists were excavating a megalithic Neolithic tomb, which is essentially a massive stone-built communal grave.
A very significant site.
And inside, they found the burials of infants. But they weren't standard burials. The items buried with these infants and even the shrouds themselves were heavily painted with Tyrian purple dye.
The presence of Tyrian purple in a 6,300-year-old context just cannot be overstated. We really need to look at how that dye is actually produced to understand the significance.
Right, because it doesn't come from a plant or a berry.
No, not at all. Tyrian purple, historically known as royal purple, is extracted from a predatory sea snail, specifically the murex snail.
Snails? Really?
Yes. And the process is unimaginably labor-intensive. You have to harvest tens of thousands of these specific snails from the ocean floor, extract a tiny gland from each one, and leave them to rot in massive vats under the sun for days.
Oh, gross. The smell must have been horrific.
The stench was historically legendary, but the resulting dye was color-fast and incredibly vibrant. Because of the sheer manpower required to produce a single gram of it, Tyrian purple was literally more valuable than its weight in gold.
Okay, wait, hold on. I need to process this.
Sure.
If the prevailing theory in archaeology is that early agricultural societies were mostly egalitarian, meaning everyone shared the workload and the wealth, or that any status you had was earned by being a great hunter or a wise elder.
Right, the meritocracy theory.
Exactly. But an infant hasn't had time to hunt or farm. An infant hasn't earned anything. So if you're burying a baby in the Neolithic equivalent of a multi-million-dollar royal shroud, then you're looking at undeniable proof of inherited wealth.
Are you saying we have proof of trust funds and entrenched class systems from 6,000 years ago?
It certainly challenges the romanticized notion of a purely egalitarian prehistoric past. It proves that rigid social hierarchies, the concept that some bloodlines are inherently superior to others, regardless of individual merit, existed thousands of years earlier than our written records indicated.
That is just wild.
It raises a very uncomfortable, deeply political question that sociologists still argue over today, honestly. Is deep economic inequality an inherent, unavoidable byproduct of human beings settling down and accumulating resources?
That is a heavy realization. It implies that the moment we stopped wandering and started building walls, we started building class divisions right along with them.
Exactly. Wealth concentration seems to be a very old human habit. But history isn't just about ancient bones and royal snails. Sometimes it's literally buried in a farmer's field, just waiting for a guy with a metal detector.
The rise of the citizen historian. It's a wonderful trend.
Exactly. Let's talk about the Vikings. If you grew up watching movies, the narrative is incredibly simple, right? Vikings were brutal raiders with horn helmets, which I know is historically inaccurate, who jumped off longships, burned monasteries, and went back to Scandinavia.
A very one-dimensional view, yes.
But a massive influx of new archaeological discoveries, specifically the Galloway Hoard in Scotland, and a huge wave of Danish coin hoards, are painting a totally different picture. They were incredibly sophisticated global traders.
And the influx of data we're getting from Denmark is largely due to a very specific and brilliant piece of legislation called the Danefæ Law.
Yes, I was reading about this. It's brilliant policy. The Danefæ Law essentially states that any historical treasure pulled out of the earth belongs to the state. It's public domain. But instead of just confiscating it, like a lot of places would, the government fully compensates the finder based on the market and historical value.
Which completely undercuts the black market.
Exactly.
If a hobbyist metal detectorist finds a Viking hoard, they don't have to melt it down or sell it to a private collector in the shadows just to make money. They hand it over to the National Museum, they get paid fairly, and the historical context is preserved for the public.
And because of that, we're looking at things like the Galloway Hoard. And what is inside it is just mind-blowing. It's not just a bunch of hacked-up silver coins.
No, it's a global collection.
It contains intricately carved Anglo-Saxon brooches, Irish silver arm rings, and even a heavily decorated vessel from the Carolingian Empire, which would be modern-day France and Germany. There is even silk that originated in the Byzantine Empire.
It reveals a massive economic network. The Vikings weren't just raiding, they were curating wealth. They understood international exchange rates. They established trade routes stretching deep into the Middle East and Central Asia. They essentially acted as the logistical connective tissue of a heavily fractured medieval Europe.
And it's amazing that so much of this is being found by regular people. There is a sheer romance to it, haha.
There really is.
Like the Wallach family in Wisconsin, right here in the U.S. A father and daughter were just out fishing on Lake Michigan. They were using a consumer-grade, underwater drone-like, the kind you can buy online for a few $100s. And they stumbled across a 151-year-old shipwreck sitting perfectly intact at the bottom of the lake.
The democratization of exploration technology is shrinking the globe in the best way possible. We used to rely exclusively on massive state-funded research vessels to map the ocean floor. Now, a family on a weekend fishing trip is contributing to the maritime historical record.
It's brilliant. But while citizens are scanning the shallow lakes, state-funded science is using tech to solve much deeper mysteries. Up in the Canadian Arctic, researchers just used advanced DNA sequencing to finally identify the remains of 4 sailors from the doomed 1845 Franklin expedition.
The British voyage that completely vanished while trying to navigate the Northwest Passage.
Right. For nearly 200 years, these guys were just anonymous bones scattered across the ice. Now, because we can sequence DNA from a fragmented jawbone, we can match it to living descendants. We pulled their names out of the ice.
It bridges the gap between the past and the present in a very visceral way, doesn't it?
Yeah.
We're using our mastery of the microscopic, the ability to map the invisible genetic code to bring resolution to historical tragedy.
Yeah, it's powerful stuff.
But what is truly staggering is that the exact same ambition that drives us to map the invisible code in a sailor's bones is now driving us to map the invisible forces of the universe itself.
This is where things start to sound like literal science fiction. If you think a hidden fault line under Seattle is hard to see, try looking for dark energy.
It's the ultimate hidden force.
Because NASA, the National Aeronautics and Space Administration, is gearing up for a mission that makes finding a lost shipwreck look like child's play. They're preparing the Nancy Grace Roman Space Telescope for a September 2026 launch.
The Roman Space Telescope is an infrared observatory, which means it sees the heat signatures of the universe rather than the visible light we see with our own eyes.
Okay.
And its primary mission is to observe hundreds of millions of galaxies to measure the expansion of the universe, basically attempting to quantify dark matter and dark energy.
But the part of this mission that is absolutely blowing my mind is that it's going to reveal millions of invisible neutron stars.
Neutron stars are perhaps one of the most extreme physical phenomena in the cosmos.
Tell us more about that. What makes them so extreme?
Well, when a massive supergent star runs out of fuel, it collapses under its own immense gravity in a supernova explosion. What is left behind is the core, the neutron star.
Okay, so it's a dead star core.
Right. And they're incredibly small, perhaps only 12 miles across. But they are so dense that a single teaspoon of neutron star material would weigh billions of tons here on Earth.
Billions of tons in a teaspoon, that's impossible to even picture.
It defies earthly logic. But they don't emit a lot of visible light. They are just these dark, unimaginably heavy spheres lurking in the void.
So if you can't see them and they don't emit much heat, how does the Roman telescope find them?
Through a mechanism called gravitational microlensing, which relies entirely on Albert Einstein's theory of general relativity.
Okay, break this down for us, because gravitational microlensing sounds like something straight out of Star Trek.
It does. Imagine you're looking at a bright, distant star. Now imagine an invisible neutron star slowly drifting between your telescope and that distant star.
Okay, I'm picturing it.
Because the neutron star is so incredibly dense, its gravity physically warps the fabric of space-time around it. It creates a literal dip or a bowl in space.
Like a bowling ball on a trampoline.
Exactly. So when the light from the bright background star hits that warped space, it doesn't travel in a straight line anymore. It follows the curve.
Oh, like looking through the thick base of a wine glass?
That is an excellent analogy. The gravity of the invisible neutron star bends and magnifies the background starlight, creating a momentary flare of brightness.
I see.
Even if the Roman telescope cannot see the neutron star itself, it is sensitive enough to detect that highly specific, fleeting magnification of the background star. We are literally seeing the invisible by observing how it violently distorts the reality around it.
That is just, it's humbling. We are tracking ghosts by watching the curtains flutter.
Beautifully put.
But NASA isn't just staring off into deep space, you know? They are playing a wildly complex game of orbital billiards right here in our own solar system. Let's talk about the Psyche mission.
Yes, the Psyche probe. It's currently en route to a very rare, entirely metallic asteroid, which is also named Psyche. Scientists believe it might be the exposed iron-nickel core of an early planet that had its crust blasted away billions of years ago.
A naked planetary core flying through space.
Exactly.
But to get there, it needs a boost. On May 15th, the probe is making a ridiculously close flyby of Mars. I mean, it's coming within 3,000 miles of the Martian surface. It's doing this to steal orbital momentum, a gravity assist, to slingshot itself out into the asteroid belt.
Gravity assists are a standard mathematical staple of orbital mechanics. We have been doing them since the Voyager missions. But what elevates this event is the unprecedented coordination happening on the ground.
Right, because while the Psyche probe is screaming past the planet at thousands of miles an hour, NASA has the Curiosity rover down on the surface of Mars, operating around Sol's 400-893 to 400-899 of its mission.
Right.
And the rover is actively drilling into a red sandstone formation they named Campo Marte, named after a geological formation in Bolivia. And while it's drilling, they're pivoting its atmospheric sensors upward.
Looking up at the flyby.
Exactly. Curiosity is taking ground truth measurements of the Martian atmosphere at the exact same time the Psyche probe is flying overhead, creating a synchronized data set spanning from the dirt to orbit.
It is a phenomenal logistical achievement. And understanding the Martian atmosphere is critical right now, especially given the recent data from the EVAN orbiter regarding the SWAN-Wolf effect.
I was hoping we'd get to this because this sounds totally counterintuitive. Mars does not have a global magnetic field. Earth does, and it protects us. Mars lost its global shield billions of years ago, which is why its atmosphere was mostly stripped away.
That's the generally accepted timeline, yes.
So how on Earth or how on Mars is it exhibiting complex magnetic space weather?
It is true that the planetary dynamo deep inside Mars died long ago.
Yeah.
But the crust of the planet still holds localized, fragmented pockets of magnetism. Think of them as magnetic fossils trapped in the rock.
Magnetic fossils, okay.
Now, the sun is constantly blasting out a stream of highly charged particles called the solar wind. When this solar wind hits Mars, it interacts with the upper atmosphere in these localized magnetic pockets, essentially tangling with them and creating what we call magnetic flux tubes.
So the SWAN-Wolf effect is what happens inside those tubes.
Exactly. As the solar wind wraps around the planet, the charged particles get squeezed, compressed, and accelerated along these magnetic flux tubes. the plasma becomes incredibly dense and chaotic.
So even without a global shield, the ghost of Mars's magnetic past is still violently wrestling with the solar wind.
It proves that planetary protection against space weather is not a simple binary of having a shield or not having a shield. It's a highly localized, turbulent interaction.
Which means it's unpredictable.
Very much so. And if humanity ever intends to establish a permanent, sustainable presence on the surface of Mars, we have to map these chaotic magnetic zones because that radiation will directly impact the astronauts and their equipment.
And speaking of equipment, we can't rely on astronauts remote controlling every single piece of machinery, and we certainly can't rely on a mission control center in Houston trying to joystick a rover with a 20-minute communication delay.
No, the latency makes that impossible.
Which is why NASA's high-performance spaceflight computing project, the HPSC, is such a massive deal. They just developed a new radiation-hardened AI space chip.
The historical bottleneck in deep space exploration has always been raw computing power.
Why is that? I mean, my smartphone can process billions of calculations a second. Why are space rovers running on processors from the 1990s?
Because your smartphone would die instantly on the surface of the moon.
Haha, really?
Instantly. Almost instantly. In the vacuum of space, you don't have Earth's atmosphere protecting you from cosmic rays and heavy ions. When one of those highly charged particles strikes a standard silicon computer chip, it can cause what we call a single event upset.
What does that mean?
It literally flips a microscopic digital 1 to a 0. On a rover, that bit flip could tell the navigation system to drive off a cliff, or it could simply crash the entire operating system.
Oh, wow. So a single particle can kill a billion-dollar mission.
Exactly. To prevent this, space-grade processors are built with massive physical redundancies. They are physically larger, much simpler, and therefore incredibly slow compared to consumer tech.
But this new HPSC chip changes the architecture, right? It's radiation-hardened, but it has the multi-core processing power to actually run artificial intelligence algorithms locally on the spacecraft.
It is the paradigm shift from a remote-controlled drone to a truly autonomous robotic explorer.
That's huge.
It is. With this chip, a rover on Mars doesn't have to stop, take a picture of Boulder, send it to Earth, wait 20 minutes for the signal to arrive, wait for humans to analyze it, and wait 20 minutes for the command to drive around it.
It can just figure it out on its own?
Exactly. The rover can process the visual data, recognize the hazard using its neural network, and independently calculate a new route in milliseconds.
It's giving the machine its own brain. But even with AI taking the wheel in deep space, NASA still desperately relies on human intuition for the really complex pattern recognition. They are running these citizen science projects right now. One is called Shock Detectives, and another is Space Umbrella.
This is a fascinating intersection of public engagement and high-level astrophysics. They are asking volunteers, regular people with a laptop, to analyze data from the Magnetospheric Multiscale Mission, or MMS.
Right. The MMS satellites are orbiting Earth, flying right through the boundary where the solar wind slams into Earth's magnetic field, and they're recording the plasma shocks.
Yes, massive amounts of data.
But the data sets are so huge, and the difference between a peaceful shock wave and a chaotic shock wave is so visually nuanced that human eyes are actually better at sorting it than standard algorithms.
The overarching goal here is planetary defense. When those chaotic plasma shocks breach our magnetic field, they induce geomagnetically induced currents on the surface of the Earth.
Which means electricity where we don't want it.
Right. These currents can flow into our electrical transmission lines, overload transformers, and completely fry regional power grids. By having citizen scientists map these shocks, we are essentially crowdsourcing the predictive models needed to protect our global infrastructure.
I love that. We're building AI to explore Mars independently, but we need high school students on their laptops to help protect the power grid in Ohio.
It's a wonderful collaborative effort.
And sometimes looking back at Earth gives us the most surprising and beautiful data of all. We have to talk about that Artemis II image.
Oh, it is a remarkable technical achievement in remote sensing.
A giant radio telescope on Earth turned its dish toward the moon, and it managed to capture a radar image of the Orion capsule flying around the lunar surface with the Artemis II astronauts inside. The quote from the lead astronomer was just chilling. There are 4 people in those pixels.
To resolve an object the size of an Apollo-era command module from nearly 240,000 miles away is staggering.
But an even more impactful view of humanity from space comes from NASA's Black Marble project. They've been analyzing global light radiance data from 2014 to 2022, and the results are profound.
Very illuminating data, no pun intended.
Haha. Overall, the Earth got 34% brighter, but it's not uniform at all. In the United States, the West Coast got significantly brighter, but the East Coast actually got dimmer.
This is where astrophysics intersects directly with sociology and economics.
So break that down. How does the glow of a city at night act as an economic footprint?
It is a direct, unfiltered reflection of human behavior, municipal policy, and demographic shifts. The west coast of the U.S. getting brighter correlates tightly with massive population growth, urban sprawl, and the expansion of logistical hubs operating 24 hours a day.
Okay, but the East Coast isn't emptying out. New York and Washington, D.C. are still packed. Why are they getting darker?
Because of policy and infrastructure upgrades.
Oh, really?
Yes. The dimming on the East Coast is largely attributed to the aggressive adoption of energy-efficient LED lighting. Municipalities are replacing older, omnidirectional sodium streetlights with targeted LED fixtures that focus the light downward onto the street rather than bleeding it up into the atmosphere.
Oh, so it's less light pollution, not less people?
Exactly. Globally, the data is even more stark. If you look at specific regions in India or China, the sudden, massive explosion of nighttime radiance directly tracks with rapid, state-sponsored industrialization and the aggressive expansion of the middle class into newly built urban centers.
By measuring photons hitting a satellite, NASA is actually mapping global supply chains, energy policy, and the relentless migration of human ambition.
It's a literal map of our progress, glowing in the dark.
And that ambition is driving us toward a future that, quite frankly, feels like science fiction. Let's bring this deep dive back down to Earth, specifically to the bleeding edge of biology and technology.
The realms of artificial intelligence and deep tech.
Right. And right now, the entire AI industry has been holding its breath over a massive legal drama that just concluded. Elon Musk just lost his landmark $150 billion lawsuit against OpenAI and its CEO, Sam Altman.
This was a highly watched federal trial. Ultimately, the jury dismissed all of Musk's claims.
Yeah. For context, Musk helped found OpenAI, but he left the board years ago. He was alleging intellectual property theft and breach of contract.
Yes, his core argument was about the company's trajectory.
His argument was that Altman and OpenAI had abandoned their original founding mission, which was to operate as a nonprofit developing AI for the benefit of all humanity, and instead pivoted into a closed, highly secretive, for-profit model heavily aligned with massive tech monopolies like Microsoft.
The legal resolution was essentially procedural. The jury determined that Musk simply waited too long to file the suit under the statute of limitations and therefore dismissed the claims.
So they didn't even rule on the philosophy of it.
No, they didn't. However, analyzing this impartially requires looking at the philosophical friction this trial exposed, which remains entirely unresolved.
You're talking about the divide between open source ideals and commercial reality.
Precisely. On one side of the political and technological spectrum, you have the foundational open source argument. The belief here is that artificial general intelligence is a technology so profound, so capable of altering human history, that it must belong to the public domain.
So no one company owns the future.
Exactly. It must be democratized, transparent, and decentralized to prevent a single corporation from monopolizing the future.
And Musk was leaning heavily into that narrative.
He was. But on the other side of the aisle, you have the staggering commercial reality of modern frontier AI. Training these massive neural networks requires billions of dollars in specialized silicon chips and immense amounts of electricity.
Right, you can't run that on bake sales.
No, you cannot. You cannot fund that level of capital expenditure purely through nonprofit donations. To secure the computing power necessary to stay at the cutting edge, companies argue they have to pivot to structures that offer a return to institutional investors.
It's the classic tension between utopian ideals and the brutally expensive realities of industrial-scale innovation.
A tale as old as time, really.
And while the billionaires are battling in federal court over who controls the master models, the actual technology is quietly filtering down and being democratized anyway. We're seeing companies like Sandbox AQ doing something incredible.
They really are making strides.
They're integrating their highly specialized drug discovery models directly into AI assistants like Anthropic's Claude.
Which represents a profound paradigm shift in scientific research.
It really does. Before this, if you wanted to model how a specific protein interacts with a synthetic chemical, you needed a PhD in computational biology and access to a supercomputer.
The barrier to entry was incredibly high.
Now they're plugging that capability into an interface that understands plain English.
It acts as a universal translator. It removes the friction between a biologist's intuition and the incredibly complex mathematics of molecular chemistry.
Exactly. It's like we used to need a master linguist to read the ancient scrolls of molecular biology. Now AI is acting as a universal translator earpiece. Any scientist with a good idea can understand the language and test a hypothesis.
It really accelerates the pace of discovery.
And it's not just happening in science, it's happening in the creative space, too. A startup called Runway, which builds AI video generation tools for filmmakers, is pivoting to take on Google and their Gemini model directly.
And their strategy differs significantly from the major tech conglomerates.
Yeah, Google and OpenAI often focus on full automation-like. You type in a prompt, the machine spits out a finished, polished product. But Runway is focusing on user-generated creativity.
Empowering the creator rather than replacing them.
Exactly. They're building tools that allow a video editor or a director to meticulously control the AI output, adjusting lighting, camera angles, and physics frame by frame. They want to empower the artist's specific vision, not just replace the artist with an automated content slot machine.
It is the fundamental difference between viewing AI as a human replacement versus viewing it as a cognitive exoskeleton, a tool designed to amplify human capability rather than render it obsolete.
A cognitive exoskeleton. I like that. And we are going to need every ounce of that amplified capability to tackle the ultimate human problem, aging and disease.
Yes, the biology segment.
Let's move into the biology segment of our data stack, because this is arguably the most revolutionary part of the deep dive.
The breakthroughs currently occurring in biotechnology are redefining the boundaries of human longevity.
Let's start with a wild idea from a grad student that just sparked a major breakthrough. They figured out a way to use aptamers to selectively target and tag senescent cells.
We should probably define senescent cells for the listener, as they are the primary culprit in the physical deterioration we experience as aging.
Yeah, good idea. What are they?
As human cells divide over a lifetime, their DNA accumulates damage. Eventually, to prevent becoming cancerous, a cell will permanently stop dividing.
Okay, so it retires.
Basically.
Yeah.
But instead of dying and being cleared away by the immune system like it should, some of these cells enter a state of senescence.
Researchers call them zombie cells, right?
A fitting term. They just sit in our tissues, refusing to die, and they begin secreting a toxic cocktail of inflammatory chemicals that degrade and damage the healthy cells around them.
Gross.
Very. This localized inflammation is what drives tissue decay, arthritis, and organ failure.
Right. So the holy grail of anti-aging research has always been finding a way to kill the zombies without hurting the healthy cells next to them. And this grad student realized they could use aptamers.
Yes, aptamers are fascinating molecules.
They are synthetic, single-stranded DNA or RNA molecules, right? And they're created through a process called SELEX.
Systematic evolution of ligands by exponential enrichment.
Aha! I knew you would know the acronym. But break down the mechanism for us. How does SELEX actually work?
Imagine you have a highly complex lock, which is the unique protein receptor on the surface of the zombie cell, and you need a perfectly shaped key to open it.
Okay, a lock and key.
Instead of trying to calculate and design the perfect key from scratch, SELEX essentially takes a billion random microscopic molecular shapes and throws them all at the lock simultaneously.
It's brute force biology.
Exactly. You wash away the 999 million shapes that do not stick. You take the 3 or 4 molecules that kind of grip the lock, you multiply them, you mutate them slightly to create variations, and you throw them at the lock again.
Wow, so you're just accelerating natural selection.
You repeat this cycle dozens of times. It is forced rapid evolution in a test tube. Eventually, you evolve an aptamer that perfectly, exclusively grips the surface of the zombie cell.
So once the aptamer tags the zombie cell, it acts like a laser designator. Doctors can theoretically attach a localized toxin to the aptamer, inject it, and it will hunt down and clear out only the senescent cells, leaving the healthy tissue untouched.
It is precision anti-aging.
And this targeted approach complements another deeply fascinating recent study regarding exosomes.
Yes, the gut particles.
Right. Researchers have found that tiny particles in the gut microbiome, these exosomes, actually cross into the bloodstream and drive aging across the entire body by promoting systemic inflammation.
The gut-brain axis and the gut-body axis are proving to be central to our overall health.
But here's the crazy part, and this sounds like alchemy. They found that introducing exosomes extracted from young animals into the guts of older animals actually mitigated the age-related damage.
It's remarkable, isn't it?
The young particles basically circulated through the old tissue and chemically signaled the old cells to repair themselves.
It suggests that aging is not merely a passive wearing down of the biological machine, like tread on a tire. It is an active, ongoing signaling pathway.
So we can hack the signal.
That's the implication. If the gut is broadcasting a decay signal as we age, it implies that with the right intervention, we can hijack that pathway and broadcast a repair signal instead.
And we're already seeing that kind of reversal happen in real time with neurodegenerative diseases. Scientists just used a breakthrough in nanotechnology to successfully reverse Alzheimer's disease in mice.
The distinction between managing and reversing cannot be overstated here. For decades, billions of dollars in Alzheimer's research have resulted primarily in symptom management.
Just slowing the inevitable.
Right. The goal has been to simply slow the cognitive decline by clearing out the amyloid plaques in the brain.
But this new nanotech approach didn't just slow it down. The researchers deployed nanostructures that actively promoted the regeneration of synapses. The mice didn't just stop declining, they recovered their lost memories and their cognitive function returned to normal baseline levels.
It represents a fundamental paradigm-altering shift from managing the decay to actively rebuilding the neural architecture.
It's the literal application of advanced engineering principles to organic biology.
It truly is.
And speaking of blurring the lines between biology and engineering, scientists at the University of California, Santa Barbara, just pulled off something incredible. They essentially bottled the sun.
A very poetic way to describe a highly complex biomimetic energy storage mechanism.
I mean, they created a liquid battery that stores solar energy, but it doesn't store it as electricity. It stores the energy inside tiny, custom-designed molecules, and they based the entire design on the reversible structural changes we see in human DNA.
The mechanism is elegant. When you expose this liquid to sunlight, the photons hit the molecules and force them to fundamentally change their physical shape.
They bend.
They snap into a new higher energy configuration, essentially trapping the solar energy within their chemical bonds.
And because it's trapped chemically, not electrically, you can store that liquid in a tank at room temperature for years without losing the charge. Then, when you need the power, you pass it through a catalyst, the molecules snap back to their original relaxed shape, and they release the stored heat or electrical energy.
The implications for global energy infrastructure are massive. We are currently entirely reliant on lithium-ion batteries to store renewable energy, but lithium requires highly destructive rare earth mining, and the batteries degrade over thousands of charge cycles.
They wear out.
Nature, however, has been storing solar energy in chemical bonds through photosynthesis for billions of years without degradation. By mimicking the structural mechanics of DNA, these researchers have bypassed the limitations of lithium entirely. Just a closed-loop liquid system that shrinks the sun.
It is absolutely amazing. We're literally reprogramming life and mimicking nature to solve our biggest existential problems.
However,
Uh-oh. I knew a however was coming. The tone shift.
it is necessary. Because while our technology is advancing at an unprecedented, almost exponential rate in the laboratory, nature is currently pushing back in the real world with a force that threatens to overwhelm all of those advancements. We really must transition to the global climate and health data.
Yeah, it is incredibly sobering. While we're figuring out how to live forever and bottle the sun in a lab in California, the actual world outside is teetering on the edge. Let's look at the climate chaos currently sweeping the globe. The World Meteorological Organization, the WMO, just dropped a massive report on Latin America and the Caribbean, and the data is devastating.
The statistical extremes of the last century are rapidly becoming the baseline normal for this century.
Exactly. Mexico recently recorded temperatures hitting 52.7 degrees Celsius, that's over 126 degrees Fahrenheit. At the exact same time, 85% of the country was facing a severe multi-year drought.
Unbearable conditions for agriculture.
Down in the Caribbean, Hurricane Melissa, a catastrophic Category 5 storm, slammed into Jamaica, killing 45 people and wiping out coastal infrastructure. And high up in the Andes Mountains, the glaciers are retreating so rapidly that it's directly threatening the drinking water and agricultural supply for 90 million people.
What we are witnessing is the total destabilization of the hydrologic cycle. The physics of it are straightforward but brutal.
How so?
When you introduce record-breaking heat into the atmosphere, the air expands and holds significantly more moisture. Over the oceans, this leads to the rapid intensification of catastrophic storms like Melissa.
More fuel for the hurricane.
But over land masses, that same superheated atmosphere acts like a giant sponge, baking the soil dry and creating megadroughts.
And the Andes glaciers?
The glaciers act as the natural, slow-release reservoir for the entire continent. They accumulate snow in the winter and slowly melt in the summer, providing a steady stream of fresh water during the dry season.
So if they're gone, what happens?
The loss of that buffer means the region will swing wildly between flash flooding when it rains and absolute arid drought when it doesn't. It is a cascading failure of regional ecosystems.
And it's not just the equator taking the hit. Down at the South Pole, Antarctica is facing what scientists are calling a triple whammy of unprecedented sea ice loss.
This is perhaps the most critical data point in the climate segment. The white sea ice of Antarctica acts as Earth's primary air conditioner.
Right.
It reflects a massive amount of incoming solar radiation back out into space, a phenomenon known as the albedo effect.
But as the ice disappears, it exposes the dark ocean water underneath.
Yes. And dark water absorbs solar heat instead of reflecting it. This creates a deeply dangerous feedback loop. The ocean warms, melting more ice, exposing more dark water.
It just accelerates itself.
But beyond the warming, the freezing and melting of Antarctic ice drives the deep ocean thermohaline circulation, the massive underwater currents that dictate global weather patterns. Altering that system alters the climate of every continent on Earth.
And we are feeling those altered patterns right now, literally everywhere. Delhi in India just recorded its hottest May day in 2 years, hitting 45.1 degrees Celsius. And here in the U.S., a massive, highly organized, severe weather outbreak is currently tracking across the central states.
The storm system is immense.
We are talking a squall line stretching from Kansas and Nebraska straight through Iowa and pushing all the way up to Maine. 50 million people have been put under active tornado warning.
It is a relentless, exhausting barrage of atmospheric kinetic energy.
And when it's not raining, it's burning. In California, the Sandy Fire in Simi Valley just scorched 1,300 acres, threatening suburban neighborhoods. And in a bizarre, deeply tragic incident, a separate wildfire on the isolated Channel Islands off the California coast was sparked entirely by a single man crashing his vehicle into the dry brush.
It highlights how vulnerable and primed these parched landscapes are. The environmental tinderbox is so dry that a single mundane human accident can instantly ignite an inferno.
And the brutal reality is that when the environment collapses, human health follows right behind it.
I want to lean on your expertise here. If we connect this to the bigger picture, how do these massive climate extremes directly impact global health emergencies?
They act as a profound, overarching threat multiplier. You simply cannot separate human epidemiology from environmental stability.
Which brings us to the latest alert from the World Health Organization. The WHO just declared an Ebola outbreak in the Democratic Republic of Congo, the DRC, and neighboring Uganda, as a public health emergency of international concern, or a PAEIC.
A very serious declaration.
Currently, there are 8 lab-confirmed cases, but local authorities are tracking over 80 suspected deaths. And the ripple effects are global. You know, an American citizen recently tested positive after traveling, which immediately prompted the U.S. to institute deep screening protocols at major international airports.
To answer your question about the climate connection, when extreme weather destroys agricultural yields and dries up traditional water sources, it completely destroys the local economy.
Right. People can't farm. This forces large human populations to migrate in order to survive. This forced displacement inevitably pushes humans deeper into previously isolated, deeply forested areas in search of food, timber, and bushmeat.
Which drastically increases human contact with wild animal populations.
Exactly. It drastically increases the statistical probability of a zoonotic spillover event.
And a spillover is when a virus jumps species, right?
Correct. when a pathogen like the Ebola virus jumps from an animal host like a fruit bat into a human. Furthermore, these climate-displaced populations often end up gathering in massive under-resourced refugee camps or urban slums where sanitation is severely compromised.
Which is the worst place for an outbreak to start.
Once a zoonotic spillover occurs, the crowded, unsanitary conditions allow the virus to spread at terrifying speeds.
It's a domino effect. The drought causes the migration causes the spillover, the poverty causes the outbreak. And it's not just new outbreaks we have to worry about, it's the total collapse of the defenses we already spent decades building. Winnie Byanyima, the executive director of UNAIDS, just issued a terrifying public warning. The global infrastructure for HIV prevention is in a state of collapse.
And this collapse is driven entirely by economics and geopolitics, not by a failure of medical science.
Yes, the numbers in the report are heartbreaking. The use of PrEP, which is the highly effective daily pill that prevents HIV infection, dropped by 31% in Uganda and a staggering 64% in Burundi.
That is a massive reduction in preventative care.
Why? Because the international funding simply vanished, the clinics could not afford the medication, so they closed their doors, and the immediate devastating result. Right now, according to the data, 570 young women are contracting HIV every single day.
If we look at the systemic level, we see a brutal chain reaction. Wealthy donor nations in North America and Europe are increasingly turning their political and financial focus inward.
They're looking at their own problems.
They are dealing with their own domestic inflation, the political unrest of their own populations, and the immediate staggering financial costs of rebuilding after the extreme weather events we just discussed. As a result, international foreign aid budgets are the first to be slashed.
So a hurricane in Florida or a drought in Europe essentially defunds a clinic in Burundi.
Precisely. The economic strain of the climate crisis in wealthy nations directly leads to the defunding of vital health programs in developing nations, leading directly to a resurgence of entirely preventable diseases. The globe is intricately, inescapably interconnected.
Which proves that navigating these massive natural, technological, and biological shifts requires incredibly steady, unified global leadership. But when we look at the political data stack, the current geopolitical map is deeply, deeply fractured. We're on a geopolitical chessboard, and everyone is playing a different game.
The diplomacy of the 21st century is fraught with a level of tension and rapid oscillation that we have rarely seen in modern history.
Let's start with the two biggest players on the board. U.S. President Donald Trump recently met with Chinese President Xi Jinping in Beijing, China. And the contrast in their diplomatic approaches was stark, almost theatrical.
It was a fascinating display of contrasting diplomatic doctrines.
Trump took a highly personalized, very flattering approach during the public press conferences. He publicly called Xi a warm person and heavily praised his leadership style. Interestingly, prior to the summit, Xi had made a public post asserting that the United States was in a state of rapid decline under the previous Biden administration.
Yes, setting the stage, so to speak.
And during this summit in Beijing, Trump actually publicly agreed with Xi's assessment. But while Trump was utilizing heavy flattery and agreeing with criticisms of his predecessor, Xi remained incredibly resolute, formal, and immovable on China's core state interests.
From an analytical standpoint, this reflects two fundamentally different strategies of statecraft.
How so?
President Trump's approach is deeply rooted in his background as a real estate developer. He often relies on interpersonal rapport, highly publicized flattery, and personal charm as a tactic to disarm counterparts, cut through bureaucratic red tape, and open doors for immediate transactional deals.
And Xi Jinping's strategy.
Xi's resolute demeanor is a projection of the Chinese Communist Party's institutional strategy. He is communicating that China operates on long-term, immovable state policy, not personal relationships. By remaining formal, he is signaling to both the U.S. and his domestic audience that personal rapport will not alter China's strategic, decades-long objectives.
So did the differing strategies actually result in anything? Expectations for a massive trade deal were very low going in, and frankly, there were no sweeping structural breakthroughs regarding tariffs.
Well, as expected.
However, China did agree to buy 200 Boeing jets, which is a massive, multi-billion-dollar economic transaction that certainly plays well for American manufacturing. But arguably, the most important outcome of the summit wasn't about traditional trade at all. The U.S. and China formally agreed to establish a framework to start discussing AI safety.
That's a critical, potentially historic development. Despite their intense economic competition and escalating military rivalry in the Pacific, Both nations clearly recognize that unchecked, rapidly evolving artificial intelligence poses an existential threat that does not respect national borders.
Wait, you're comparing AI to nuclear weapons?
It is the closest historical parallel we have. Establishing a bilateral framework for AI safety between the world's two superpowers is akin to the early nuclear non-proliferation treaties of the Cold War. It is a mutual acknowledgement of mutually assured destruction if the technology is allowed to scale without human oversight.
But while they're agreeing to talk about AI, the traditional military rivalry is still a massive powder keg. During the summit, President Trump explicitly warned Taiwan not to go independent. And this happens at the exact same time that Taiwan is aggressively pushing for a massive new U.S. arms deal to defend itself against potential Chinese military aggression.
This encapsulates the incredibly delicate tightrope of the One China policy and the doctrine of strategic ambiguity.
Okay, unpack strategic ambiguity, because it sounds like an oxymoron. How can a strategy be ambiguous?
It is a deliberate diplomatic balancing act that the U.S. has maintained for decades. The U.S. does not formally recognize Taiwan as an independent sovereign nation, acknowledging Beijing's claim.
Okay.
However, the U.S. maintains robust economic ties with Taiwan and is legally bound by the Taiwan Relations Act to provide Taiwan with the means to defend itself. The ambiguity lies in the fact that the U.S. purposefully does not state definitively whether it would intervene militarily if China attacked Taiwan.
So it keeps everyone guessing.
Exactly. The goal of the strategy is dual deterrence. The U.S. is attempting to deter China from taking Taiwan by force by leaving the threat of U.S. military intervention on the table. Simultaneously, the U.S. is attempting to deter Taiwan from formally declaring independence, which Trump was echoing, because a formal declaration would almost certainly trigger a Chinese invasion. It is an attempt to freeze the status quo.
A status quo that feels like it could shatter at any moment. And the Pacific isn't the only flashpoint. Over in the Middle East, U.S.-Iran tensions are oscillating wildly. Admiral Brad Cooper recently testified to the U.S. Senate, stating categorically that recent U.S. and Israeli military strikes severely degraded Iran's military capabilities and weapons manufacturing facilities.
A significant public assertion of force and strategic degradation.
Yes, but the whiplash of modern diplomacy is wild here. Shortly after that aggressive Senate testimony, President Trump publicly expressed deep impatience with Iran's leadership, but then abruptly called off a scheduled secondary military strike. He cited that the two nations are actually in serious negotiations toward a comprehensive peace deal.
This is a textbook application of the maximum pressure doctrine, followed by an immediate off-ramp.
How does that work? You hit them and then ask for peace?
Essentially, yes. By severely degrading the military capabilities first, the U.S. attempts to negotiate from a position of absolute, undeniable strength. You apply maximum kinetic pressure to demonstrate consequences, and then you abruptly offer the cancellation of further attacks as a diplomatic carrot. The goal is to force Iran to the negotiating table by making the alternative too costly to bear.
And the U.S. is utilizing similar pressure tactics much closer to home, right in the Caribbean. The director of the CIA, the Central Intelligence Agency, John Ratcliffe, just made an unannounced, highly unusual visit to Havana, Cuba, to deliver a direct, in-person message from President Trump.
The domestic situation in Cuba is currently in an incredibly dire state.
They're facing a catastrophic energy crisis. We're talking about rolling blackouts across the entire island, hospitals losing power, and an economy grinding to a halt, largely driven by a strict U.S. fuel blockade. According to reports, Ratcliffe delivered a blunt message. He demanded fundamental changes in the Cuban government structure and explicitly warned Cuba against strengthening its military or intelligence ties with Russia and China.
This is a modern, aggressive application of the Monroe Doctrine.
The idea that the Western Hemisphere is essentially U.S. turf.
Correct. The U.S. is utilizing economic strangulation via the fuel blockade to foment domestic unrest, hoping to force political regime change from within. Simultaneously, the direct CIA visit is a stark warning to global adversaries. The U.S. is making it abundantly clear that it will not tolerate adversarial superpowers like Russia or China attempting to exploit Cuba's economic desperation to establish a geopolitical foothold 90 miles off the coast of Florida.
The sheer weight of managing all of this is staggering. But here's where it gets really interesting and, frankly, a bit chaotic. We expect national leaders to masterfully manage these massive international crises, but they are simultaneously dealing with intense political turmoil and societal unrest right in their own backyards.
Domestic instability inevitably limits a leader's foreign policy capital.
Look at the United Kingdom right now. The ruling Labour Party is in absolute crisis. Health Secretary Wes Streeting just abruptly resigned his cabinet position, publicly stating a total loss of confidence in Prime Minister Keir Starmer's leadership.
That's a massive blow to the Prime Minister.
There are credible reports leaking that nearly 90 Labour MPs are actively organizing and questioning Starmer's political survival. And waiting in the wings, you have Andy Burnham, the highly popular mayor of Greater Manchester, officially making a bid to return to the House of Commons in the Makerfield by-election, clearly positioning himself as a potential alternative leader for the party.
It is a classic, brutal internal power struggle, and it is deeply exacerbated by the immense pressures of governing in a post-Brexit, heavily economically strained landscape where public services are struggling. When the public is unhappy with the economy, the ruling party inevitably fractures as factions try to distance themselves from the leader's sinking approval ratings.
And economic strain doesn't just cause political resignations, it causes literal explosions. In South America, the situation in Bolivia has boiled over into violence. In the capital city of La Paz, miners armed with dynamite have clashed violently with riot police.
Dynamite in the streets, that is an extreme escalation.
They are protesting a severe, crushing economic crisis marked by massive inflation and crippling fuel shortages. They are in the streets demanding the immediate resignation of President Rodrigo Paz.
The use of dynamite by the miners is a visceral, terrifying symbol of the explosive desperation felt by the populace. When basic necessities like fuel for transport and affordable food become entirely inaccessible, the foundational social contract between the government and the governed breaks down entirely. The state loses its legitimacy, and you see a rapid descent into violent civil unrest.
And finally, we have to address a deeply tragic event of societal unrest right here in the U.S. because it ties into the technological forces we discussed earlier. In San Diego, California, there was a horrific shooting at a local mosque that left 3 innocent people dead. 2 teenage suspects were also found dead at the scene.
It's just an awful situation.
Local police and federal authorities are currently investigating this as a potential hate crime, largely driven by a suicide note left by the teenage suspects that was heavily laced with racial and religious hatred.
It is a profound, senseless tragedy. And while we must let the investigation conclude, analyzing this impartially requires us to look at the deeply concerning, overarching trend of youth radicalization.
How does a teenager get to that point?
This is where we must reckon with the dark side of the technology we discussed earlier. The proliferation of hate rhetoric is increasingly accelerated by the engagement algorithms of digital platforms.
Social media algorithms.
Yes. These recommendation engines are designed to maximize user watch time by serving increasingly extreme, emotionally activating content. A vulnerable individual can start by watching mildly controversial political content, and within weeks, the algorithm isolates them in an echo chamber of violent, extreme ideologies.
Algorithmic radicalization.
Exactly, and it can lead directly to devastating real-world violence.
It's heartbreaking. And it raises urgent societal-level questions about community safety, mental health interventions in schools, and our collective responsibility to counter extreme ideologies before they manifest into a tragedy like San Diego. And it brings up the question I promised earlier. How can modern leaders possibly manage local tragedies, internal party revolts, and delicate international peace deals, all in the exact same 24-hour news cycle?
The sobering reality is they cannot. It is an impossible balancing act. The human brain simply did not evolve to process compounding, simultaneous global crises.
So what do?
Leaders are forced to rely on vast, unwieldy bureaucratic architectures and, increasingly, on the very AI systems we discussed, just to parse the sheer volume of daily data. But the ultimate decisions, whether to authorize a military strike on Iran, how to equitably distribute pandemic funding, how to mourn and respond to a domestic tragedy, those remain deeply flawed human choices.
Which brings this entire deep dive full circle. From the 3.8 million-year-old bones of Australopithecus anamensis fighting for survival in an Ethiopian valley, to the AI chips preparing to make autonomous navigational decisions on the dusty surface of Mars. Humanity is constantly surviving, constantly adapting, and constantly discovering.
We have spent this entire session examining hidden forces. We've developed the miraculous technology to see the invisible. From mapping the gravitational pull of dark matter and distant neutron stars in deep space, to pinpointing the silent secondary fault lines buried beneath our largest cities.
It really is miraculous.
We can sequence the DNA of a sailor lost in the Arctic ice for 150 years. We can literally bottle the sun in a custom-engineered liquid molecule.
We can see and measure almost everything.
We can. But looking at the deeply fractured state of global diplomacy, the tragic violence in our streets, and the civil unrest driven by economic despair. Perhaps the hardest hidden forces to map and the hardest to control are the psychological and sociological forces driving human behavior itself.
That is profound.
We have engineered absolute miracles of science. But if we can figure out how to bottle the sun, can we engineer a way to peacefully, equitably share the Earth? That is the question that remains unanswered.
That is the ultimate diagnostic muddy water. The X-ray machine cannot show us the fractures in our own society. We have to figure that out ourselves. Thank you for joining us on this deep dive. Keep questioning the world around you, keep looking for those hidden forces, and above all, keep learning and stay curious. Haha. See you next time.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. Right now, in the streets of La Paz, Bolivia, miners are hurling dynamite in violent protests against their government.
Yeah, literally throwing dynamite.
Right. And halfway across the world, in Japan, wholesale inflation is, quietly devastating the grocery bills of millions of families.
Mm-hmm.
At first glance, these seem like completely isolated regional crises, but they are not. They are directly connected by a fundamental tectonic shift in how the world's most powerful nations conduct business. So today, we are exploring the planetary implications of a new era of aggressive transactional diplomacy.
That's right, because the post-World War II diplomatic consensus, which relied on predictable alliances and, slow multilateral institutions, is actively fracturing.
Exactly.
High-stakes summits where, everything is treated as a bargaining chip.
Which brings us to the central question we are debating today. Does this current era of transactional diplomacy effectively recalibrate unfair global power dynamics? Or does it inadvertently fracture the planetary economy, destabilizing vulnerable nations and driving adversaries into alternative anti-Western alliances?
Right, and we are drawing this debate directly from recent pivotal global developments.
Yes, specifically, we'll be looking at the outcomes of the high-stakes U.S.-China summit in Beijing, the abrupt cancellation of NATO troop deployments to Europe, and the cascading economic crises sweeping from Cuba to Bolivia all the way to Japan.
Because look, you cannot look at these events in a vacuum. The planet is an interconnected ecosystem.
Exactly. I will be arguing that maximizing pressure and treating security and trade as transactional leverage is a necessary, realist corrective that forces both adversaries and allies to the negotiating table to finally fix a fundamentally broken global system.
And I will be arguing that this transactional framework is dangerously short-sighted, driving a wedge through the global economy and pushing targeted nations to build resilient, anti-Western geopolitical blocks that will eventually shut us out.
So let's lay out the foundation of our positions here. For decades, the global economic and security architecture has been, deeply unbalanced.
Mm-hmm.
Traditional diplomacy, the kind characterized by polite summits, endless multilateral working groups, unconditional security guarantees, it has simply failed to yield structural results.
Well, I wouldn't say
It created an environment where adversaries like China could exploit global trade rules, and allies in Europe could systematically underfund their own defense because, frankly, they knew the West would always foot the bill.
right.
Applying maximum leverage forces nations to realistically assess their positions. We are seeing this now. The U.S. is demanding structural changes from Cuba in exchange for $100 million in aid amidst their crippling oil crisis.
Yeah.
Or consider the weapon sales to Taiwan being used as a direct bargaining chip in trade negotiations with China. This isn't diplomacy by committee, It is diplomacy by leverage.
Mm-hmm.
Disruption is a feature, not a bug here, and we are seeing it yield acknowledgments. The U.S. and China are finally initiating bilateral discussions on artificial intelligence safety, and the U.S. Trade Representative has noted that China is beginning to fulfill its trade promises.
I see why you think that, but let me give you a different perspective. A shock to the system is exactly what the system required to function equitably again.
I'm sorry, but I just don't buy that. Let me tell you why.
Okay.
Treating the planetary economy and international security as a series of hostile,
zero-sum business transactions, it doesn't recalibrate the world order. It accelerates global instability.
How so?
Well, sovereign nations are not corporations. You cannot just launch a hostile takeover of a country's foreign policy. Nations are driven by nationalism, historical grievance, domestic political survival. When you squeeze them, they don't necessarily fold. Sometimes they do.
They adapt. And this strategy is currently backfiring on a planetary scale. We saw this vividly in Beijing. The U.S. president brought top American CEOs to China, employing flattering rhetoric, explicitly expecting major trade breakthroughs, but no significant deals emerged.
Right, but Xi Jinping remained entirely resolute because Beijing views the U.S. as a declining power. Furthermore, this economic squeezing actually isolates the West. Because of the U.S. fuel blockade, Cuba is not capitulating.
They are in crisis, though.
They are, but instead of folding, they are turning to Russia. They're surviving on a single Russian oil tanker and partnering with China to build solar infrastructure. We are not forcing compliance, we are forcing our adversaries to innovate around us. But see, this strategy of squeezing allies and adversaries only makes sense if you understand the underlying mechanics of leverage. Let's move right to the epicenter of this dynamic.
The U.S.-China relationship.
Right, the U.S.-China relationship. You point to the lack of immediate, sweeping trade deals in Beijing as a failure. But if you're listening to this and wondering why no grand bargain was struck, it's because a lack of immediate victory is standard in high-level transactional negotiation.
Is it?
Yes. The goal wasn't just to sell goods. It was to force China to recognize the mechanical link between regional stability and global trade.
By holding regional stability hostage?
By establishing clear geopolitical boundaries. For instance, the U.S. strategy of pausing military attacks on Iran at the specific request of Gulf leaders, combined with aggressively leveraging Taiwan arms sales, it sends a highly calculated message to Beijing.
Which is?
It says access to Western markets and regional stability are commodities, and they require your cooperation. The long-term play is securing vital commitments. And it works. We saw commitments for 200 Boeing jets.
Mm-hmm.
And more importantly, we saw the initiation of those U.S.-China AI safety talks. You cannot separate the economic leverage from these diplomatic openings.
Let's unpack that, because I think the Boeing deal illustrates exactly why this approach is flawed. Purchasing 200 Boeing jets isn't a structural reform.
It's a massive economic commitment.
It's a standard transactional sweetener. It's what you buy when you want to look cooperative with actually changing your domestic policies.
I think that's a bit cynical.
The fundamental flaw in the transactional approach is the assumption that the other side has no leverage of its own. The U.S. brought the titans of American industry to Beijing, signaling a desperate appetite for market access. Xi Jinping read that desperation perfectly. He offered a resolute stance because this shows us the new rule of global trade. Market access is no longer enough to buy geopolitical compliance if a nation values long-term economic self-sufficiency over, quarterly earnings reports.
Well, I don't disagree that China values self-sufficiency, but you can't ignore the friction this dynamic creates for them.
The friction is spreading, yes, but not in the way the West wants. Look at Europe. The European Union recently expanded its sanctions from Russia to encompass China.
Which aligns with Western interests.
But it proves that the global economy is actively splitting into opposing blocs. Rather than conforming to U.S. pressure, China is solidifying its position as the center of an alternative economic universe. When the U.S. Secretary of State, Marco Rubio, visits China under the cloud of existing sanctions, it highlights how convoluted this transactional strategy has become. It's contradictory.
It is complex, certainly, but it's not contradictory. Leveraging Taiwan's defense and tech dominance is like negotiating the price of a fire extinguisher while the house is actively burning.
Right.
It assumes the market will wait for the transaction to clear. But doesn't the initiation of bilateral AI safety talks prove that when the stakes are genuinely existential, China will come to the table?
When the technology threatens the very fabric of global security, the transactional mindset forces them to sit down because the cost of being excluded from the regulatory framework is just too high.
They come to the table for AI safety because uncontrolled artificial intelligence threatens their domestic stability just as much as ours.
But the leverage got them there.
It has nothing to do with us withholding a trade deal or leveraging weapons to Taiwan, and this brings us perfectly to how this transactional mindset treats security. It commodifies it. It turns military alliances into line items on a balance sheet.
It brings accountability. We are seeing the alienation of traditional allies because of this exact philosophy. Let's look at NATO. The Pentagon recently and abruptly canceled the deployment of 4,000 U.S. troops to Poland.
Which was a necessary correction.
It was a profound shock to the European defense architecture. We are talking about Article 5 commitments here, the foundational principle that an attack on one NATO member is an attack on all.
I mean, no one is abandoning Article 5.
But treating European security as conditional, as something that can be revoked if a ledger isn't perfectly balanced, deeply frustrates European allies. The mechanism of this is dangerous. If Poland can't rely on the U.S. troop presence, they have to instantly pivot to panic buying their own armor, destabilizing the unified defense strategy.
They should be buying their own armor.
And then, contrast that sudden withdrawal with what we are doing in the Middle East. The Middle East requires a different posture entirely.
But look at the discrepancy. Admiral Brad Cooper recently testified before the Senate that U.S.-Israeli strikes have severely degraded Iran's military and defense capabilities.
Right, neutralizing a threat.
We are seeing a dangerous reliance on kinetic military action and ad hoc strikes in one region while abandoning stable, long-term diplomatic alliances in another. We pull troops from Poland, but launch kinetic strikes in the Middle East. It projects erraticism, not strength.
That's an interesting point, though I would frame it differently. It doesn't project erraticism at all. It projects a long overdue recalibration of resources based on actual mechanical threat assessments.
Recalibration by abandonment? Alliances must reflect the geopolitical realities of today, not the Cold War nostalgia of the 1980s. The cancellation of the troop deployment to Poland isn't an abandonment of Article 5. It is a blunt signal that European nations must physically shoulder their own defense burdens. How does that work mechanically? When we pull 4,000 troops, it forces domestic parliaments in Europe to allocate real GDP percentage points to their militaries instead of social programs. For too long, the U.S. has subsidized the security of wealthy industrialized nations. By treating these deployments as conditional, we are demanding equitable partnerships.
By burning the trust that holds the partnership together.
Trust requires mutual effort, and conversely, in the Middle East, the U.S. is demonstrating military capability exactly where it mechanically matters.
Yeah.
Degrading Iran's military capabilities through targeted strikes while concurrently pausing other operations at the request of Gulf allies demonstrates a highly calibrated use of hard power. We are actively managing a volatile region while forcing our European partners to step up. It is the definition of holding allies accountable while neutralizing active threats.
But holding allies accountable through sudden unilateral withdrawals breeds deep systemic mistrust. And when you combine that military mistrust with the economic weaponization we discussed earlier, the planetary fallout becomes devastating.
Devastating is a strong word.
We cannot just talk about generals and CEOs, right? We have to look at the tangible human and economic consequences in the global south. The planetary economy is bleeding from 1,000 transactional cuts.
I think bleeding is a fast overstatement of a necessary market correction.
Let's trace the mechanics of this so-called correction. Look at the severe ripple effects of economic blockades in Latin America. CIA Director John Ratcliffe made an unprecedented visit to Havana recently. This happened amidst a devastating U.S.-imposed fuel blockade. Let's explain how that works. It's not just ships turning around. U.S. sanctions threaten the international banking and insurance mechanisms that marine vessels rely on.
Exactly.
Which means oil tankers physically cannot dock in Cuba without risking massive financial ruin. This has plunged the island into darkness. And what is the diplomatic strategy? Dangling $100 million in humanitarian aid while simultaneously planning to indict former leader Raul Castro for the 1996 downing of the Brothers to the Rescue civilian planes.
An indictment that is legally justified and, frankly, morally necessary.
Perhaps, but diplomatically, it is a staggering cognitive dissonance. You cannot say, here is a lifeline to save your collapsing energy grid, in one breath, And we are going to criminally indict your foundational leadership for a 30-year-old event in the next.
Leverage works on multiple fronts.
It's highly punitive, and it isn't productive. And this energy weaponization ripples outward. Look at Bolivia. Right now, there are violent protests by mining groups utilizing dynamite against President Rodrigo Paz's government. Why? Because of severe dollar and fuel shortages.
Right.
The interconnectedness of the global economy means that squeezing one node creates a crisis in another. Even highly developed nations aren't immune. Japan is currently experiencing a massive spike in wholesale inflation. Why? Because when energy markets in the Atlantic and the Middle East are disrupted by blockades and kinetic strikes, Asian markets are forced to overpay for liquid natural gas just to keep the lights on. That cost is passed directly to the Japanese consumer.
I'm not convinced by that line of reasoning because it misdiagnoses the root cause of the economic pain in these regions.
How so?
The crises in Havana and La Paz are not primarily the result of Western diplomatic pressure. They are the terminal stages of failing domestic structural policies and alliances with adversarial states.
Wait, you think the U.S. banking blockade has no effect on Havana's grid?
It has an effect, sure. But Cuba's energy crisis is fundamentally the culmination of decades of a mismanaged command economy and a disastrous reliance on a now distracted, sanctioned Russia. The fuel blockade simply accelerated an inevitable collapse.
I see.
The CIA directive's visit wasn't just punitive. It was a strategic opening. The mechanism of leverage here is clear. It was a message that a pathway back into the Western economic fold exists, provided they enact fundamental market changes and physically distance themselves from Beijing and Moscow.
By starving them out in the dark?
By showing them that their current alliances cannot sustain them. Similarly, the dynamite protests in Bolivia are fundamentally a domestic reaction to local policy failures. You mentioned the dollar shortages, but let's look at how that happened.
Okay.
The unrest was sparked by President Paz's canceled land mortgage law. When that law was canceled, foreign investment fled, which instantly created a massive dollar shortage. Compound that with the severe multi-year decline in their natural gas production, which destroyed their export revenue, and the government can no longer subsidize fuel for the miners.
Right.
That is why they're throwing dynamite, to blame transactional Western diplomacy for the failures of Bolivian resource management or Cuban economic planning removes all agency from those sovereign governments.
That's a compelling argument, but have you considered the macroeconomic reaction to this strategy? Even if we grant the domestic mismanagement plays a significant role in Bolivia or Cuba, weaponizing access to dollars and energy accelerates the very thing the West fears most, de-dollarization.
Well, de-dollarization has been a talking point for decades, yet the dollar remains the reserve currency.
Because the alternatives hadn't been forced to mature yet. We are forcing them to mature right now.
I don't know about that.
If you're listening and wondering what de-dollarization actually looks like, look at the SWIFT banking system. It's the messaging network banks use to move money securely around the globe. When the West uses access to SWIFT or global fuel markets as a bludgeon, we provide an empirical case study for why nations must diversify away from Western institutions. If Cuba can manage to survive on a single Russian oil tanker and Chinese-built solar panels, aren't we just incentivizing the global South to build an entirely separate economic ecosystem?
We are forcing them to choose a side.
We are forcing them to build a parallel infrastructure. When Japan, a steadfast Western ally, suffers crippling wholesale inflation because global energy supply chains are being used as geopolitical chess pieces, they too begin to look for more resilient, diversified energy partnerships.
Right.
We are pushing the global economy into a bifurcated state. Eventually, Western sanctions will lose all their teeth because half the planet will be operating on a financial network that doesn't even touch New York or London.
Let's summarize our positions in light of this incredibly complex landscape.
Sure.
My position remains that the old diplomatic consensus was actively harming global stability by allowing structural imbalances to fester. Polite requests don't change state behavior. Consequences do. Leveraging our economic and security assets, whether through targeted blockades that choke off adversarial funding, conditional troop deployments that force allies to invest in their own defense, or making trade contingent on geopolitical cooperation, It's the only realistic way to break through diplomatic stagnation.
Right.
It forces structural reforms and realistic assessments from Havana to Beijing to Brussels. Disruption is the prerequisite for a more equitable global alignment.
And my summary is that this transactional maximum pressure approach is dangerously fracturing the planet. By treating international relations as a series of zero-sum business transactions, we are isolating Western powers and exacerbating severe humanitarian and economic crises in vulnerable regions like Bolivia and Cuba.
Okay.
Instead of bringing adversaries to heel, we are incentivizing the creation of an entirely separate anti-Western economic and technological bloc. We are trading long-term global stability for short-term leverage, and it will ultimately diminish our own security.
I think where we fundamentally converge today is on the acknowledgement that the global economic order is undergoing a permanent shift. The days of a single unipolar economic consensus where one bloc dictates all the terms are decidedly behind us.
Absolutely.
We also clearly agree that energy access and technological dominance, particularly in realms like artificial intelligence, are the new primary currencies of geopolitics, far outweighing traditional military posturing.
Yes, we agree on the shifting dynamics of the world order. Where we remain fundamentally opposed is on the prognosis. You view these diplomatic pressure tactics as the necessary friction required to settle the global system into a fairer, more balanced formation.
I do.
I view them as the fractures preceding a catastrophic bifurcation of the planetary economy, one that will leave us isolated from the fastest-growing markets on Earth.
It reflects the deep complexity of a fully interconnected planetary economy. We live in a world where a targeted policy decision to restrict banking access in Washington or a resolute stance taken on self-sufficiency in Beijing can directly trigger dynamite protests in the streets of La Paz or cause a household's grocery bill to spike in Tokyo.
And because of that interconnectedness, the shifting dynamics of global supply chains, multipolar alliances, and resource scarcity mean that every action has a profound, often unpredictable reaction across the globe.
Exactly.
It requires us to continuously explore the mechanisms behind these headlines and question the assumptions driving this new diplomatic era.
We leave the final judgment to you, the listener. The global landscape is changing rapidly. The friction of these new policies is very real, and the mechanisms of leverage are shifting before our eyes. We'll see where the fault lines ultimately settle. Thank you for joining us on The Debate.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.